Hello everyone and welcome to a fresh discussion under this groundwater engineering course, and here we are going to talk about groundwater quality. Indirectly in several previous discussions we have touched about groundwater quality. So, when we say groundwater quality, what we mean basically, and how it is assessed and what is the importance, all these things we will be discussing here. So, groundwater quality basically, like in our surface water bodies in lakes, rivers, oceans, is a critical for the quality, overall quality of our lives. Because if our rivers, lakes and even the oceans, seas are getting polluted, then it will affect our life directly. So, that is what overall we think from groundwater quality point of view, that what is the effect it is going to cause to us, not only for our lives, but animal lives. They are also important of our food cycle. So, this about the determination of groundwater quality, and that is the what are the things which are in form of solution. So, solutes and gases dissolved, that is another very important thing here. What are the gases which are dissolved in water, or the matter which are suspended or floating on the water. Many substances which are floating currently may get dissolved with water, and they may create a big deterioration in the water quality. So, all kinds of concerns should be addressed here. So, water quality is a consequence of natural, physical and chemical state of water, as well as any alteration that may be or may have occurred as a consequence of human or natural activity or human interventions. So, lot of deterioration, if at a wherever it is happening in case of groundwater quality, is mainly human interventions. Human activities are causing deterioration of groundwater quality, not only for the surface water bodies, but also subsurface aquifer conditions. So, there we have to also think what is the good water quality and what is bad, or what are those parameters on which it is assessed, that we will discuss. Now, usefulness of water for a particular purpose is determined by water quality. Whether water is for drinking, then it has to be pure as per the standards available, or if it is being used for industry, then what kind of quality of water is required, and whether the same quality as drinking water or maybe less quality water, and if it is being used for agriculture purposes, then what kind of water quality is required. I gave example in the previous discussion that the sewer water which is coming through a house based or municipal waste, that is being recycled and being used for gardens and maintenance of greenery. Can we use the same quality of water for agriculture also? So, that kind of knowledge is required, and this is how the water quality should be assessed. That if a less not drinkable water, if it is put in agricultural field, what harm it will create, what kind of problems it will create. So, that is also there. As said earlier or just mentioned, that human activities, human interventions alters the natural water quality, and water quality to that so that it no longer fit for use directly without filtering or without any kind of treatment which had previously been suited. That means in an area where no such human or major human interventions were not there, less population was there, not any industry was there, no waste disposal sites. So, in that area the water was suitable for drinking, for human consumption. But now because of population, because of industry or some other reasons, the water is no more suitable for drinking or for human purposes. So, we have to assess again that why it has become like this. So, water is said to be polluted or contaminated when this thing all happens. So, it should be, it is important that in many areas water quality has been altered by human activities. Overall, like if I give example of India, in many places, the same water quality which we used to have 20-30 years back is no more exist, because of lot of human activities which are altering our groundwater regime. So, first of all, we are looking a classification scheme for water based on TDS. TDS is total dissolved solids. So, what are the basic measures of groundwater quality? And first we will look the TDS, which is the total amounts of solids in milligrams per liter, and that remain when a water sample is evaporated to dryness. So, this is how it is measured. So, if we say fresh water, then the TDS should be in the range of or I would say less than 1000 milligram per liter. But if it is brackish water, this is the range which is 1000 to 10,000, and in case of saline water 10,000 to 1 lakh, and brine water is more than 1 lakh. So, that kind of TDS level. So, we are basically looking for all our purposes, for drinking, for industry, for other things, we are looking TDS of this range. So, naturally water naturally contains a number of different dissolved inorganic constituents, and the major anions are calcium, magnesium, sodium, potassium. Major cations are chloride, sulphate, carbonate and bicarbonates. So, a natural water may have all this. Calcium is being seen at various places that it is carrying lot of calcium, the natural water which is coming. So, because why calcium? The water is coming through calcium rich rocks. So, that is getting dissolved and it is coming in our water system. Similarly, magnesium, sodium and other potassiums and other things are there. So, there may be minor constituents also apart from calcium, magnesium or cations and ions, that like means iron, manganese, fluoride, nitrate and boron. This fluoride is in many places, this fluoride is creating big problem in terms of groundwater quality and causing lot of problems to the humans and of course the animals also, those who are consuming that kind of water. So, many areas are getting this fluoride problem in India. So, further the water, natural water may also, or natural whatever the water we are consuming may have trace elements such as arsenic, lead, cadmium, chromium, all are very, very harmful for the humans, even a small quantity. So, these are also present only in the few milligram per liter. So, of course, there are standards. If any of such these elements are present in the water, then they have to be assessed through those standards, whether the water is drinkable or not, or consumable, or can be used for agriculture. So, they are important from water quality standpoint. The water quality should be assessed based on the parameters which we have discussed. Now, dissolved gases which are also present in both in surface and groundwater, and major gases which concerns are oxygen and carbon dioxide, and nitrogen which is more or less inert is also present. Lot of fertilizers which are being used, and that is bringing nitrogen in our water regime also. There are minor gases which are like hydrogen sulfide. Sometimes the water gets a lot of bad smell, gives lot of bad smell because of this. Many these reservoirs, large bigger reservoirs are also creating methane, and which is getting disposed in the atmosphere directly. So, these are the gases which are concerned from groundwater quality view. So, hydrogen sulfide is the toxic, imparts a bad odor, but is not present in water that contains dissolved oxygen. So, if oxygen is sufficient amount of oxygen is there, then we will not have hydrogen sulfide. So, minor gases you might have seen in many water bodies, they have put lot of fountains, so that the water is rich in oxygen. When water goes and it collects absorb the oxygen available in the atmosphere and comes back again. So, if you go in any major lakes, like if I give example of Dal lakes, they are having too many such fountains for aeration. They say aeration, so that the water which comes in the air for maybe 20-30 meters for a few seconds, it absorbs the oxygen and comes back. So, by which the bad odor, or that means hydrogen sulfide, can be reduced when we are having more dissolved oxygen in the water. Minor gases are concerned, which are minor gases, hydrogen and methane, these are important one. Hydrogen sulfide is toxic, we have seen all this, we have just discussed about this. Now, surface water may be adversely impacted by human activities, because initially what is being surface waters, especially river waters, we are seeing all over the country. And under this Namami Gange project, this is what being done to make water as good, as pure as possible. So, the water even which originates from, say if I give the example of Ganga, originates from Gomukh, from Uttarakhand, that to some extent that too is carrying some pollutants to some minor quantity, minute quantity. So, that means these things, even our glaciated water, because the Gomukh is nothing but the snout of a glacier. So, glaciated melt water is coming, and that is carrying some kind of pollution. That means our glaciers are also getting polluted, glacier water is also getting polluted. But can we maintain even whatever is there, can we maintain and can so that we do not dispose the municipal water and other things into the river. So, this is what is being done extensively under this Namami Gange, and to many stretches starting from top has been cleared, means the water, waste water is not coming, industry water is not coming into the Ganga, and it is before treatment. So, after treatment only it is coming. So, if it is done, then it is fine. Now, we also get in groundwater quality, we also consider the organic matter. Earlier we have been considering inorganic matter, dissolved gases, now organic matter. So, untreated human or animal waste, which is also getting mixed with our surface water, especially I have mentioned about streams or rivers or also ponds, surface water, dissolved oxygen level. If it is high level is there, then it is diminished, microorganisms grow using the organic matter as an energy source and consuming oxygen in the process. So, TDS may increase if these things are there owing to disposal of wastewater. So, TDS is one important parameter to assess the groundwater quality, as we have seen, starting from fresh water to saline water, brackish water and other. Urban runoff. Urban runoff means the water which is coming into the stream through this from the cities, and increased erosion due to land use changes in the drainage basin. So, these things are happening, and these things are harming our groundwater quality everywhere almost. So, there is a classification of groundwater quality on Indian standards and WHO. So, on the second column we are having Indian standards, on the last column we are having on right side we are having World Health Organization standards. So, if we consider like TDS, TDS is given here as 500, and in case of WHO it is 1000, bicarbonate, chloride, sulphate, calcium, magnesium, these are the inorganic and organic or inorganic things which we have just discussed, up to even fluoride. So, the limit here is 1.2, whereas WHO says it is, but even a very minute quantity of fluoride is very harmful for the humans and animals or living beings. Potassium also, magnesium, sodium, all kinds of things are there. So, the natural quality of groundwater varies spatially, location to location, because the geology is different, because of the human activities are different, human interventions are different, and therefore, there is a variation all over the places about the groundwater quality. And like TDS ranges, because of these variations, can range from 100 milligram for some fresh groundwater to even 1 lakh milligram for some brines found in the deep aquifers. So, sometimes even in the groundwater regime we get of this kind of TDS, which becomes our water is non-usable in that sense. Now, water quality standards in India. So, for drinking water, which we say class A, that we are having different parameters and their ranges also, like pH should be between 6.5 to 8.5, dissolved oxygen 6 milligram per liter or more, biochemical oxygen demand 5 days on 5 days basis, that 20 C square mg or mg per liter. Now, outdoor bathing, that kind of, if it is then like in holy rivers people go. So, what kind of standards are there as per Indian standards, that this dissolve again pH should be between 6.5 to 8.5, this is almost same as drinking water. And there are oxygen level changes, biochemical oxygen demand, and also there. Then drinking water sources after conventional treatment and disinfection. If it is being done, then again these parameters are defined here. And then propagation of wildlife and fisheries, where it is being done, then pH is 6.5 to 8.5, is so same as for fresh water and other waters. Dissolved oxygen 4 mg per liter or more. Free ammonia, that is also range is given here. So, we are having our own Indian standards for water quality, and that should be whenever the water is being used or any kind of problems are being created for water, these standards should be followed so that we get the correct water. If especially I am talking about the water which is being consumed by humans, that those standards should be followed very strictly, otherwise it will harm lot of health issues which is already harming in case of fluoride and other things. Now, for irrigation, industrial cooling, controlled waste disposal, other, that is the category E, pH is, earlier we were saying 6.5 to 8.5, now it has come to 6. So, more acidic can be allowed. Electrical conductivity, sodium absorption ratio and boron maximum, these are, and the standards have to be followed, and below E is not meeting A, B, C and E criteria. That is really having not good for any kind of consumption, that is put as below E. As we know that the sources, so in this schematic all these sources are being shown here. About the pesticides, this is the non-point source pollutants. Source pollutants are there, point source pollutions are there, waste lagoon, I was talking about fly ash. So, if it is a thermal power plant, it is putting a waste lagoon, or some other sources are there on this figure. Sewer waste is also coming from cities, urban areas. So, the pollution of surface water frequently result in a saturation where the contamination can be seen or smelt, and that is what is major concern. So, however, contamination of groundwater most often results in a siltation that cannot be detected by human senses, and so this is a problem. Now, chemical and microbiological agents that are adversely impacting the quality of groundwater, which water coming from variety of sources. So, microbiological things are also there, lot of research is being done on this also. Can these organisms can be used even to reduce the pollution in the groundwater? So, that kind of research is also going, but nonetheless whatever the these things are coming. So, land application of agriculture chemicals, that I have said, lot of fertilizers, insecticide, pesticides, that is one of the non-point source pollution. Annual waste, the septic tank disposal systems for sewage, and then sewage treatment lagoons, land application of organic waste, municipal landfills, toxic and hazardous waste landfills, then this leaking underground storage tanks or leaching from these waste sites also we can include here, faulty underground injection wells, pits, and then ponds, lagoons used for storage of this wastewater, treatment and disposal of various liquid compounds, that is also there, and chemical and petroleum product spills. You might have heard a lot of times we see about this crude oil spill in the seas and other things because some problem in the ship which was carrying or chemicals. So, all these are reasons for deterioration in the water quality. So, all these things should be monitored, there only we get the then we can have or expect at least in future a good water quality or good water or quality water. So, most common borne diseases which I was earlier mentioning, which are waterborne disease. So, these are the waterborne disease like cholera, giardia, typhoid fever, diarrhea, botulism and leptospirosis. Cholera epidemic used to happen in past, but still we get. Diarrhea is another problem. Typhoid fever in India is again another problem which is definitely related with water. So, if water quality is good, these kind of disease might not occur. So, because of several kind of bacteria or microorganisms can create these problems, which are also shown in a representative form here in the figure. As we know that many advances has been taken place to in pH or a public health system PHS and have been made, but however incidents keep occurring which are water based on these waterborne diseases and appear to be sometimes increasing. Why? Because the pollution in groundwater is increasing, our groundwater quality is getting deteriorated because of pollution, increased pollution impact because of industries and a lot of waste which is being generated, and that is not properly is being treated, and ultimately it is harming our groundwater regime. So, understanding of toxicology of carcinogenic compounds which is required, and which carcinogenic compounds here basically means which can cause cancer. Cancer can cause by many things, but we are thinking only from groundwater quality point of view, and that has increased along with the analytical capabilities to detect the low concentration of organic compounds in aqueous samples. So, our technology is improving and day by day we can do and detect even the very minute quantity of any kind of organic substances which are present in our water. So, recent regulations, or I would say not recent but continuous restrictions or these legislations are ultimately will increase the amount of groundwater monitoring requirement, and also ultimately it will hopefully it will improve our groundwater quality as well. If we follow these things and all industries and municipal waste and other things are disposed properly, then probably we will be having a good groundwater quality available for us. Numerous examples or instances are there for groundwater contamination which has been revealed in recent years also because of investigations, because of these assessments about whether some industry is causing or some disposal sites is causing. So, that kind of studies are happening. Legal cases are also being put against those who are polluting our groundwater regime as well as and also being charged for paying to the clean up the contaminated groundwater, as well as paying for the damages to the families which are suffering from illness and death. But if we talk about this very briefly, I will talk about this legal aspect. It is very difficult to prove. This is very challenging. However, if proper investigations are done, suppose in some isolation industry is there and which started polluting, and if we are having health data before that industry and after that, then probably we can put these legal cases against this. But many times these companies or industries gets free from court because it becomes very difficult to prove that they have caused the deterioration in the groundwater quality, and ultimately it has the humans have suffered or animals have suffered. So, because the challenge here is how to prove it, and that is only it is possible when we are having before industry and after industry continuous monitoring. So, if we see that certain parameters or TDS and this pH and other things levels were there before the industry has come, now it is coming, and periodically when it was checked, it was the pollutants or water quality was getting deteriorated. So, it can be attributed very clearly, it can be pinpointed that because of this industry the water quality has deteriorated, and therefore legal cases can be put against that. But as I have said, so for that, as we have been discussing in previous groundwater exploration from pollution point of view, this is what we were, the extensive information before any site is developed is collected. then these things will become, and now it is being done. So, with this I end this discussion. Thank you very much.